Hello, my name is Abdullah Muhammad. I'm a student at Borstem School and I'm a web designer. Today we are going to present a video about stoichiometry, solving some questions from Zumdhal Bank Chapter 3. And we're going to start off with the first question. The atomic mass of rhenium 186.2, given that 37.1% of natural rhenium is rhenium 185. What is the other stable isotope? 183 rhenium, rhenium 187, rhenium 189, rhenium 181, and last rhenium 190. So we have here rhenium is like the question said, 186 from the periodic table. Let's talk about the answer. First, we know that the average atomic mass equal the summation of number isotope of the element times its abundance in percentage over 100. And from the previous data we found that 186.2 equal 185 times 37.1 plus 62.9x, which is the isotope of the element over 100. And using the calculator we get 186.9, which is approximately 187. So the answer is B. Question 2. Consider the element indium, atomic number 49, atomic mass 114.8 grams. The nucleus of an atom of indium 112 contains A. 49 protons, 63 neutrons, and 49 electrons. B. 49 protons, 49 neutrons. C. 49 protons, 49 alpha particles. D. 49 protons, 63 neutrons. E. 49 protons, 112 neutrons. Try to solve this question before resuming the video. Okay? So the answer is, we can simply find out that the number of neutrons would be mass number minus atomic number, which would be 112 minus 49 equals 63 neutrons. Remember that he said a nucleus of the atom and he didn't mention the electrons. So the answer is D. Question 3. A hypothetical element consists of two isotopes of masses 69.95 AMU atomic mass unit and 71.95 AMU with abundances of 25.7% and 74.3% respectively. What is the average atomic mass of the element? 70.95 AMU, 69.95 AMU, 70.5 AMU, 71.4 AMU, and last 71.95 AMU. So like question 1, we use the average atomic mass law, isotope of the element times its abundance in percentage over 100. And from the previous data, we say that 69.95 times 25.7 plus 71.95 times 74.3 over 100 equal 71.436, which is approximately 71.4. So the answer is D. Question 4. Naturally occurring copper exists in two isotopic forms, 63Cu and 65Cu. The atomic mass of copper is 63.55 mu. What is the approximate natural abundance of 63 copper? 63%, 90%, 70%, 50%, and 30%. Pause the video and try to solve the question. Okay. Again, we use the average atomic mass law, isotope of the element times its abundance in percentage over 100. And from the previous data, we found out that 63x plus 65 100 minus x over 100 equals 63.55. Now you may wonder how we got this x and 100 minus x. From where did we get this in the previous data? Well, he said that it exists in two forms. So if the other, like for example, if the other is 40, then the other must be 60, because there are no other form. So we can say, to put it in an equation and try to solve it mathematically, that the percentage in 63 is x, and the other angle that would complete the 100% would be 100 minus x. Okay, so 63x plus 65 times 100 minus x equal 6355. Solving the equation going on, we found out that x equals 72.5%. So the closest answer is C. Question 5. Naturally occurring element x exists in three isotopic forms. X 28, which is 27.977 AMU, 92.2% abundance. X 92, which is 28.976 AMU and 4.67 abundance, and X 30, 29.974 AMU and 3.1% abundance. Calculate the atomic weight of X. A 28.09, B 48.63, C 27.16, D 28.97, E 86.93 AMU. Again, pause the video and try to solve the question. Okay, the answer. We again use the average atomic mass law, but don't get mixed up with the many numbers that he gave you, because we saw that he gives us 28, then after that he gives us like 27.977 and 29 and 28, 30, 29. Don't get mixed up in this problem. We are going to use the 27.977 AMU, which he mentioned here. So the answer, again, we use the average atomic mass law. We write down the data that he mentioned in the question over 100. So the answer would be 28.0855, approximately 28.09. The answer is A. Question 6. Again, the same question. Naturally occurring element X exists in three isotopic forms: X28, 27.977 AMU, 92.23% abundance; X29, 28.976 AMU, 4.67% abundance; and X30, 29.974 AMU, 3.1 abundance. But this time he asks what is the identity of the element X. Cu, Al, Ni, Si, Sr. In this particular question, we need the periodic table. We cannot memorize every element with its mass number, but sometimes we need to memorize some special elements, like for example hydrogen, oxygen, carbon. But in the following question we need the periodic table, so you might go and find the periodic table and start to search, and and use the mass numbers that we got from the previous question. So I already got the periodic table, and the element is Si. So the answer is D. Question 7. The average mass of a carbon atom is 12.011. Assuming you were able to pick up only one carbon unit, the chances that you would randomly get one with a mass of 12.011 is: first, 0%, B 0.011%, about 12%, 12.011%, greater than 50%. So this question is quite easy if you know the concept. There are actually no atoms that have fraction of protons or neutrons. There are like 0.11 neutron. There is not 0.11 proton. What is 0.11 is when scientists gathered the atom, tried to find the abundance of the atom in everywhere. So they found like 12 and 13, 14, for example. Then they got the average of the mass. So when they used it in the lab, they would get the 12, because it's not guaranteed that the carbons that they get in the lab, all of the atoms would be 12 or would be like 13. If we say carbon 13, so it's 12, and there are no chances that you can find an atom with mass 12.011 AMU. So the answer is A. Question 8. What is the mass of 4 atoms of copper in grams? A. 254.2 grams. B. 2.37 times 10 power 21 grams. 9.57 times 10 power negative 24 grams. 6.022 times 10 power 23 grams. 4.22 times 10 power negative 22 grams. Again, try to pause and solve the question. Okay, here is the answer. 1 AMU equal 1.66054 times 10 or negative 24 grams. Sorry, I missed adding this. So 4 copper atoms equal 4 times 1.66054 times 10 power negative 24, and time is its mass number, which is 63.546. So the answer would be 4.22 times 10 power negative 22 grams. The answer is E. Question 9. Iron is biologically important in the transport of oxygen by red blood cells from the lungs to the various organs of the body. In the blood of an adult human, there are approximately 2.64 times 10 power 13 red blood cells, with a total of 2.9 grams of iron. On the average, how many iron atoms are present in each red blood cell? Molar mass of iron equals 55.85 grams per mole. So the answer 8.44 times 10 power negative 10, 1.18 times 10 power 9, 3.13 times 10 power 22, 2.64 times 10 power 13, 6.14 times 10 power negative 2. Try to solve the question. And here we go again. The number of Fe atoms equal 2.9 divided by 58.5 times 6.022 times 10 power 23. We said the amount of iron in the human body divided by the mass number of of the iron times 6.022 times 10 power 23, which is the mole, equal 0.126 times 10 power 22. The number of iron atoms in each blood cell equals 3.126 times 10 power 22 divided by 2.64 times 10 power 13 equal 1.184 times 10 power 9. So the answer is B. Question 10. You have a symbol of zinc, Zn, and a sample of aluminum. You have an equal number of atoms in each sample. Which of the following statements concerning the masses of the samples is true? The mass of the zinc sample is more than twice as great as the mass of the aluminum sample. The mass of the zinc sample is more than the mass of the aluminum sample, but it's not twice as great. The mass of the aluminum sample is more than twice as great as the mass of the zinc sample. The mass of the aluminum sample is more than the mass of the zinc sample, but it's not twice as great. The masses of each sample are equal. Again, we would need the periodic table for this question because we need to know the mass number of aluminum and zinc. And here we have them 26.982 and 65.38. This question might seem too long and might seem hard, but it's actually very easy. The answer is that zinc has more than twice than that of aluminum. We can see here that it's 65.38, aluminum is 26.98. It should be easy. So the answer is A. Question 11. A sample of ammonia has a mass of 43.5 grams. How many molecules are in this sample? 2.55 molecules, 2.62 times 10 power 25 molecules, 2.36 times 10 power 23 molecules, 1.54 times 10 power 24 molecules, 8.63 times 10 power negative 16 molecules. Ammonia consists of nitrogen and hydrogen. So try to solve the equation and try to find how many molecules are in this sample. Okay, here is the answer. The mass of 1 mole of NH3 equal 14 plus 1 times 3 equal 17 gram per mole. So 43.5 grams equal 43.5 divided by 17 equal 2.56 moles. That's the number of moles of ammonia in the sample. So the number of atoms equal 2.56 times 6.022 times 10 power 23, which equal 1.541632 times 10 power 24, which is the answer D. Question 12. How many moles of hydrogen sulfide are contained in a 49.7 gram sample of this gas? A. 0.686 mole, 1.46 mole, 83.8 mole, 24.7 mole, 2.92 moles. Hydrogen sulfide contains hydrogen and sulfur, and here they are in front of you. So you need the mass number when you solve the equation. Try to pause the video and solve it. Okay. The mass of 1 mole of hydrogen sulfide equals 32 plus 1 times 2 equals 34 gram per mole. So 49.7 grams equal 49.7 divided by 34 equal 1.46 moles. So the answer is B. Question 13. What is the molar mass of ethanol C2H5OH? 45.06 gram per mole, 34.06 gram per mole, 46.07 gram per mole, 30.03 gram per mole, 105.03 gram per mole. And here we have the mass number of our elements, carbon, oxygen, and hydrogen. Again, try to solve the question before resuming the video. Okay. The answer. The mass of 1 mole of C2H5OH ethanol equal 12 times 2 plus 1 times 6 plus 16 equal 46 gram per mole. So the answer is C. Question 14. For which compound does 0.256 mole weigh 12.8 grams? C2H4O, CO2, CH3Cl, C2H6, none of these. So we have to get the mass number of each, we have to get the molar mass of each of these compounds in order to solve the question and find out which is the true one. Here are some elements of the following compounds. Use them to find out the answer. Try to pause the video and solve it. If you did it already, let's continue. The answer: the mass of 0.256 mole of C2H4O equal 12 times 2 plus 1 times 4 plus 16 times 0.256. We are trying to skip the part where we find out the molar mass, then we multiply it by 0.256 in order to get the equation. So we are already combining the two equations with each other. So it's equal 11.264 grams, which is definitely not our answer. The mass of 0.256 mole of CO2 equal 12 plus 16 times 2 times 0.256 equal 11.264 grams. Not our answer. Next, the mass of 0.256 mole of CH3Cl equal 12 plus 1 times 3 plus 35.5 times 0.256 equal 12.928 grams. That's very near to our answer. Let's see the last one. The mass of 0.256 mole of C2H6 equal 12 times 2 plus 1 times 6 times 0.256 equal 7.68 grams. So definitely the answer is C. Question 15. Roundup, an herbicide manufactured by Monsanto, has the formula C3H8NO5P. How many moles of molecules are there in a 295.1 grams sample of Roundup? And the choices: 0.5729, 2.137, 1.745, 16.39, none of these. Here are the elements. Use their mass number in order to find out the answer. Okay, next, the answer. The mass of 1 mole of C3H8NO5P equal 12 times 3 plus 1 times 8 plus 14 plus 16 times 5 plus 31 equal 159 gram per mole. So 295.1 grams equal 295.1 over 159 equal 1.86 mole. Okay, so the closest answer is C. Question 16. Calculate the molar mass of barium sulfite. 233.4 gram per mole, 201.4 gram per mole, 354.73 gram per mole, 514.87 gram per mole, 217.4 gram per mole. Here are the elements. Try to solve the equation or the question. Okay, the answer: the mass of 1 mole of PaSO3 equal 137.3 plus 32 plus 16 times 3, which equal 217.3 gram per mole. The closest answer is E. Question 17. Phosphorus has the molecular formula P4 and sulfur has the molecular formula S8. How many grams of phosphorus contain the same number of molecules as 4.23 grams of sulfur? 2.04 grams, 0.49 grams, 4.08 grams, 4.23 grams, none of these. Try to solve the question. Okay, the answer. First, the mass of 1 mole of P4 equal 31 times 4 equal 124 gram per mole. The mass of 1 mole of S8 equal 32 times 8 equal 256 gram per mole. The number of moles in 4.23 grams of S8 equals 0.0165 mole. We use the equation. We divided 4.23 over 256 in order to get this number. So the mass of 0.0165 mole of P4 equal 0.0165 times 124 equal 2.049 grams. The closest answer is A. Question 18. A given sample of xenon fluoride compound contains molecules of a single type xenon Fn. N is a variable number, which it's a whole number, and given that 8.06 times 10 power 20 molecules of xenon Fn weigh 0.227 grams, calculate N. N might be 1 or 6, 5, 3, or 2. Try to solve the question. The answer: the mass of 1 mole of xenon fluoride equal 6.022 times 10 power 23 divided by 8.06 times 10 power 20 times 0.227 equal 169.6 gram per mole. The molar mass equal 131.3 plus 19x equal 169.6. So what is these numbers? 131.3 is xenon, 19 is F, x here is N, and 169.6 it's obviously the molar mass. So 19x equal 38.3, x equal 2.01, approximately 2. So the answer is E. Question 19. Phosphoric acid can be prepared by reaction of sulfuric acid with phosphate rock according to the equation CS3PO4 all by 2 plus 3H2SO4 3CaSO4 plus 2H3PO4. This is products of the reaction. What is the molar mass of CS3PO42? This question might seem too long, but don't get distracted by the equation and what he says above. It's very simple. You have to find the molar mass of CS3PO42. So the choices: 310.18 gram per mole, 87.05 gram per mole, 278.18 gram per mole, 215.21 gram per mole, and 166.02 gram per mole. The answer: the mass of 1 mole of CS3PO4 by 2 equal 14 times 2 plus 2 times 31 plus 16 times 4. The answer equals 310 gram per mole, so the closest answer is A. Question 20. Phosphoric acid can be prepared by reaction of sulfuric acid. It's the same question as previous with phosphate rock, and here is the equation. But the new question here is how many oxygen atoms are there in 1.75 nanograms of CS3PO4 by 2? So again, we can neglect the exist of the equation. We just need the just need to find the answer for the question, and our only necessary thing from the equation is CS3PO4 by 2. So the choices: 3.4 times 10 power 12, 1.36 times 10 power 13, 8.43 times 10 power 15, 2.72 times 10 power 22, 2.72 times 10 power 13. So we're going to use the molar mass from the previous question, which is 310 gram per mole, and the number of molecules in 1.75 nanograms of CS3PO4 by 2 equals 6.022 times 10 power 23 over 310 times 1.75 times 10 power negative 9 equal 3.3 995 times 10 power 12. The number of oxygen atom would be 8 times 3.3995 times 10 power 12 equal 2.72 times 10 power 13. So you might wonder why did I multiply by 8? The number of oxygen atoms in one molecule of the compound is 8. Here we found O4 multiplied by 2 gives us 8, and this is answer. The answer is E. What is the mass of a 6.761 mole sample of sodium hydroxide? 40 grams, 270.4 grams, 162.3 grams, 5.916 grams, 0.169 grams. The mass of a 6.761 mole of NaOH equals 6.761 times 23 plus 16 plus 1, which equal 270.44 grams. So the answer is B. How many atoms of hydrogen are present in 7.63 grams of ammonia? So first we need to find the molar mass of ammonia in order to solve this question. 2.7 times 10 power 23, 1.52 times 10 power 24, 1.38 times 10 power 25, 8.09 times 10 power 23, 1.12 times 10 power 20. Try to solve the question. The answer: the mass of one mole of NH3 equals 14 plus 3 equals 17 gram per mole. The number of moles in the samples that he gave us is 7.63 over 17, which is equal 0.4488. The number of atoms of hydrogen equals 0.4488 times 6, 0.022 times 10 power 23 times 3, which equals 8.108 times 10 power 23. The answer is D. The molar mass of the compound formed by potassium and selenium is 157.2 grams per mole, 197 gram per mole, 118.1 gram per mole, 276 gram per mole, 196.3 grams per mole. So the compound formed is K2SE, which its molar mass equals 39 times 2 plus 79 equal 157 grams per mole. So the answer is A. Question 24. What is the molar mass of chloride? Na3AlF6, 209.9 gram per mole, 185.3 gram per mole, 210.0 gram per mole, 104.2 gram per mole, 68.97 gram per mole. Try to solve the question. So the answer: the molar mass of the formed compound Na3AlF6 equal 23 times 3 plus 27 plus 19 times 6, which is 209.94, approximately 210 gram per mole. So the answer is C. One molecule of a compound weighs 2.93 times 10 power negative 22 grams. The molar mass of this compound is A. 2.06 gram per mole, B. 567 gram per mole, C. 168 gram per mole, D. 176 grams per mole, E. None of these. So this should be easy. The molar mass of the compound equal 2.93 times 10 power negative 22 times 6.022 times 10 power 23. So 176.44 grams per mole. The answer is D. Question 26. NaHCO3 is the active ingredient in baking soda. How many grams of oxygen are in 0.52 grams of NaHCO3? 0.099 grams, 0.019, 6.19 times 10 power 3, 0.033 grams, 0.3 grams. First, we need to find the molar mass of the compound NaHCO3, which is equal 23 plus 1 plus 12 plus 16 times 3, which is equal 84 grams per mole. That is the molar mass. Now the sample is 0.52, so to find the number of moles of the sample, 0.52 over 84. I said before 0.52 moles, I'm sorry, I meant grams. So 0.52 over 84 equal 6.19 times 10 power negative 3. The mass of oxygen atom would be 6.19 times 10 power negative 3 times 16 times 3. 16 here is the mass number of oxygen, 3 is the number of oxygen atoms in one molecule, and time is the number of moles in this sample. The closest answer is E. Question 27. A compound is composed of element X and hydrogen. Analysis shows the compound to be 80% X by mass, with 3 times as many hydrogen atoms as X atoms per molecule. Which element is element X? Helium, carbon, fluorine, sulfur, or none of these? This is going to be an equation-like question, so try to solve this with yourself. From the previous data, we can deduce that 20x equal 80 times 3 times hydrogen mass. You might wonder how we got these numbers from the previous data. What is the previous data that he gave us? First of all, he gave us, let's see the question first. He said that the mass of X atom is 80%, and that hydrogen would be obviously 20%, while the number of hydrogen atoms would be 3, and X would be obviously it's going to be 1. So we throw the 80 in the opposite direction and we get the 20 with the X. So 20x equal 80 times 3 times hydrogen's mass. So solving the equation, x equal 80 times 3 divided by 20 equal 12. 12 is the mass number of carbon. So the answer is B. Question 28. Which compound contains the highest percent by mass of hydrogen? HCl, H2O, H2SO4, H2S, HF. The answer. We're going to make a comparison to see how this is going and how to find the percentage of hydrogen. So the mass number of hydrogen alone is 1, chlorine is 35.5. Here is the ratio. Hydrogen to oxygen. So it's going to and 16. The ratio is 1 to 8. That's less than before. Here we have H2 SO4 ratio to 196 148. H2S 232 1 to 16. HF 119 1 and 19. So from these tables we see that the hydrogen has the highest percentage in the compound of water. So the answer is B. Question 29. A substance contains 35 grams of nitrogen, 5.05 grams of hydrogen, and 16 grams of oxygen. How many grams of hydrogen are there in 153 grams sample of this substance? A. 7.72 grams, B. 767 grams, C. 15.4 grams, D. 5.05 grams, E. 30.3 grams. The answer The total mass here is of the first sample is 100.05, where nitrogen was 35, hydrogen 5.05, oxygen 60. The total mass in the next compound is 153, and we want to find out how the hydrogen in the compound, and it's going to be a cross multiplication. So 5.05 times 153 divided by 100.05 equal 7.72 grams. So the answer is A. Question 30. How many grams of potassium are in 27.8 grams of K2CrO7? 4.49 grams, 1.422 grams, 8.98 grams, 78.2 grams, 55.6 grams. Try to solve that question. So this is going to be easy. We need to find the molar mass of the compound. 39 times 2 plus 52 plus 16 times 7 equal to 142 grams per mole. The number of moles equal 27.8 divided by 242, the molar mass of the compound, equal 0.115. The mass of K atoms of potassium atoms equals 0.115 times 39 times 2, number of potassium in the compound, equal 8.97 grams. So the closest answer is C. Question 31. Ferrous acid HClO2 contains what percent hydrogen by mass? 1.92, 25%, 23.4%, 1.47%, 5.18%. So first we need to see a ratio between these samples, 135.5 and 32. So percentage of hydrogen equal 1 divided by 1 plus 35.5 plus 32. How did we get this formula? First, 1 is the mass number of hydrogen alone, and on the denominator, it is the mass number of or the molar number of the whole compound times 100 in order to get in percentage equal 1.46. So the answer is D. Question 32. This question might be hard, so try to focus. A mixture of KCl and KNO3 is 44.2% potassium by mass. The percentage of KCl in the mixture is closest to A 40, B 50, C 60, D 70, E 80. I'm going to give you a hint. Try to use the idea of x 100 and 100 minus x that we used in a previous question in order to get the percentage. Try to solve this equation. It's really important. The answer. First, we need to see the percentage in the two compounds for the potassium. So potassium in the first compound 39 and chlorine 35.5. The ratio is 52.35. The answer. First, we need to find the percentage of potassium in the two compounds. In the first one, potassium is 39, chlorine 35.5. So the ratio between them is 52.35% and 47.65%. The next compound, we see that potassium 39, NO3 62, 30. So the ratio between them is 38.62% and 61.38%. As I said in the hint, x, we're going to use this equation in order to find what is the percentage of KCl in the mixture. So x times the percentage of K and KCl plus 100% minus x times percentage of potassium in KNO3 equal 44.2%. that is the percentage or how much potassium he mentioned in the question. So we're going to solve this like a normal equation, but don't get messed up with the percent. The percent sign is very important, and which you would decide how this answer should be, because you might mess up trying like you might mess up the percent sign here, or maybe with 38.62, so the equation might get very wrong and you might not be able to solve it. So focus on this point. 52.35% times x plus 100% times 38.62% minus 38.62% times x equal 44.2%. Simplify this a little bit, get this part on the other side of the equation. So it's going to be 44.2% minus 38.62%. And notice here that if you didn't see here, 100% is actually 1. So 1 times 3, 8.62%, that's going to be 38.62%, of course. So making it on the other side by the negative, 44.2% minus 38.62% equal 13.75% times x. So, completing the equation normally, we get that x would be 40.6%. The answer is A. Question 33. A substance A2B has a composition by mass of 60% A and 40% B. What is the composition of AB2 by mass? 40 to A, 60 to B, 58% to A, 50% to B, 27% to A, 73% to B, 33% to A, 67% to B, and last, none of these. So A to B, we can divide it into AAB. He said that the percentage of A2 is 60, so that's going to be 30, 30, 40. The total mass would be 100, and this might seem a little bit kind of stupid. Why would you write the same thing twice? We are going to see why are we going to write this twice. Here he said the total mass, the compound would be AB2. So we're going to use the total mass that we saw in the previous question, 30, 30, 40. We're going here 30, 40, 40. So the total mass is 110. So to get it 100% and to get the other elements to percentage, we are going to do cross multiplication. So 30 times 100 over 110, 40 times 100 over 110, and again. So it's going to give us 27%, 36.5, and 36.5 again. So A equals 27%, B2 equals 73%, which would make answer C the correct one. Question 34. Each molecule of testosterone contains 19 atoms of carbon, plus other atoms. He didn't mention these atoms. The mass percent of carbon in testosterone is 79.12%. What is the molar mass of testosterone? 576.8 gram per mole, 180.5 gram per mole, 228.2 gram per mole, 240.1 grams per mole, 288.4 grams per mole. Try to solve this equation. So testosterone has 100% of the whole compound. That's very obvious. Carbon 79.12, and the other atoms would be 20.88%. And he told us that the carbon in the mole is 228.2%. So instead of getting the other atoms by cross multiplications and adding both of them in order to get testosterone, we're going to directly multiply the multiply 228.2 times 100 over 79.12, which we did here, which is equal to 128.4. So the answer would be E. Question 35. A substance contains 23 grams of sodium, 27 grams of aluminum, and 114 grams of fluorine. How many grams of sodium are there in a 102 gram sample of the substance? 4.43 grams, 23 grams, 14.3 grams, 102 grams, or none of these? The answer: the first sample is 164 grams, sodium 230 grams, fluorine 114 grams, aluminum 27 grams. The next sample has mass of 102 grams. We don't need to find the molar mass or anything like this. We can't find the molar mass. We don't have the compound in front of us, but we have some mass, and we're going to do cross multiplication here. So 23 times 102 over 164 equal 14.3. So the answer is C. Question 36. An oxide of iron has formula Fe3O4. What mass percent of iron does it contain? 0.72, 28, 30, 70, 72. So the answer is Fe3 equal 167.5, O4 equals 64, percentage of iron equal 167.5 over 167.5 plus 64, that is the molar mass of the compound times 100%, which is equal 72.35%. Thank you for listening to me. I'm going to leave you the next 36 questions from Zumdhal Test Bank to my friend Islam Muhammad, who's going to continue after me.